All right, so I'm representing the global economic modelers here, although we have Hugo's here as well, and Brian is also part of the global economic modelers. So let me get started. I'm going to start with a little bit of history first. These are price trends that come from the World Bank's Pink Sheet, which is available online. You have energy, which is the blue line, metals and minerals, the gray line, and the red line represents agriculture. And I have two trend lines in there. The orange one is the one that Excel calculates between 1960 and 2014. And the yellow one is the trend line for agricultural prices if you stopped in 2005. All right, it's called Trend 2005. So you can see that the recent crisis in agriculture, where prices for all of the commodities went up, bent that trend line pretty significantly since 2005, but the trend is still declining. And if you go back to 1900, you see the same kind of long-term price trend. So the question is, what does that imply for the future? So there are a number of studies that came out roughly around 2010 that showed very different scenarios for price trends for different periods. So you had the World Bank, which basically was me at the time, with prices continuing to decline through 2030, about 16%. And then we had kind of a low productivity growth scenario where prices would rise modestly. You could think of that as climate change. We didn't call it climate change. We just called it low productivity growth. All right. Then you had the team from Lai, now what's called the Magnet team, that had pretty significant price drops also for 2030. So again, roughly 1% a year over the 25, 30-year time span. IFPRI, on the other hand, came out with a pretty widely circulated report, Nelson et al. In 2010, and so we have prices there for rice, wheat, and maize. The first three are for a no climate scenario, so roughly rises of 20 to 30% without climate change. You can see that climate change impact is very huge. Okay, for maize, you basically would have a doubling of prices between their base year and 2050. And then Oxfam also came out with a report roughly at the same time, much higher price rises, both with climate change and without climate change. So we got a phone call from the OECD and said, what are we going to tell our agricultural ministers? How can we explain these very different views of the future of agricultural prices? And so begat basically the global economics team in AgMIP. All right, it started out just three of us. It was the World Bank, Lai, and IFPRI, with the OECD kind of coordinating us. And then Jerry Nelson got 7 other groups involved, and we've already presented those results. So essentially, we're still getting a relatively large range, I think going from roughly minus 30% for some of the models, all the way up to 40 or 50%. So the range is narrowed. AgMIP phase 1 basically narrowed the range of outcomes, but it's still very, very significant. We made some headway in trying to understand better the differences across the models. I don't think we were completely successful, but one thing we certainly recognized immediately is that we had to start with the same initial conditions. All right, so we harmonized on the key drivers, so that's basically GDP and population growth, but we also harmonized on what we call the exogenous yield growth. So we're trying to eliminate the differences in the models that were just coming out from different exogenous assumptions. All right, so the key questions, I've already gone through some of them. So production and demand, how are they're going to evolve over time? What is the impact on relative prices? What does this mean for trade, food self-sufficiency, and in some cases, some of the models are able to answer questions on nutrition as well. I think one thing we did ignore, but I think is really important, and this gets to the kind of the regional assessment, is what is going to be the future of the rural economy 40 years hence? Is Africa going to look like what it looks like today, or is it going to look like what Korea looks like today? And those are really important questions that are going to impact, again, on food security and other indicators. And then finally, the big question is, what is climate change? So Roberto actually had all these questions as well, right? And so what are the impacts on prices, trade, and food security, and then adaptation? So in phase one, we had 10 models. Basically, they can be separated into two. We have the partial equilibrium models and the general equilibrium models. I think there were 4 PEs, if I recall, and 6 GE models, all right? The models, in many cases, produce the same indicators. So changes in production, changes in demand, changes in trade, but how they get those answers is somewhat different. So many of the PE models, the big difference with the PE models is that they're really just focused on a subset of the total economy, and in this case, mostly just on agriculture. Some of the PE models may be having energy mixed in with that as well. GCAMP, for example, from PNNL, has a very developed energy submodel as well. But in general, they're taking a bunch of inputs from outside the agriculture economy as exogenous drivers for the PE models. For the GE models, basically, the GE models encompass the economy-wide factors, so it has both the ag and the non-ag sectors. It also has factor markets, and that can play a very important role, all right? The factor markets are, by and large, inexistent from most of the PE models. The other important element in a GE model, and that's what makes sometimes understanding the results complicated, is something we call closure. So since it's a global and economy-wide model, everything has to be consistent. So trade, for example, imports and exports at the global level have to balance, all right? So that's basically what we mean by closure, okay? And that means that if you take the case of India, for example, and it has a big climate shock, all right, production goes down, demand doesn't change, let's say, well, it's going to have to import additional food, right, to feed its population. By doing so, it's going to have to pay for those imports. And the GE model will tell you how India is going to pay for that extra food. So it could borrow more from capital markets, and we can model that, or it's going to have to export more. And if it exports more, that has also economic implications, because the only way it can export more is essentially by lowering its prices. All right, so there are going to be terms of trade impacts. So all of that gets caught up in the GE models. The PE models kind of sit back from some of those additional complications. The way trade is handled is also quite different. Most of the PE models have what's called the homogeneous goods trade model. So all goods, wheat that's produced by the United States is the exact same as wheat produced in Africa, and the markets then clear on a global scale. So it has implications for how prices are transmitted globally. In the GE model, normally we have with goods differentiated by origin. So a world price doesn't necessarily, 10% rise, for example, in the world price doesn't necessarily have a 10% price impact on the domestic level. All right, and those are important things. The dimensionality is quite different. The PE models typically have much more they have many more countries typically. Impact has how many now? 130 or something? 140? Whereas the GE models typically are quite aggregate, all right? And at the end I'll say what kind of complications they have. The nice thing about some of the newer PE models also is that they have, a lot of them now have production structures that are subnational. So impact, for example, divides within countries the production structures, as does Globium using grid sales. The main databases for the PE models is the FAO data, so that gives you a very broad set of commodities. GE models are typically have to use the GTAB definition, so that's basically 8 crops, 4 livestock, and 8 processed foods. So it's much more constrained in what can be.
Well, Dominique, where would the level of agriculture technology investment or R&D, where would that appear? You know, we talk about adaptation sometimes in some of the terms, and that has to do with, the example is drought tolerant or what have you, but obviously we've got great technologies that exist in certain localities that if you could just scale them, they would work probably, better than current in, let's say, developing countries. Where is there anywhere in the economic modeling kind of a low, medium, high level of ag technology investment or ag infrastructure efficacy or?
So in the PE models, typically technology will be price sensitive. There's no investment function that's going to raise productivity or anything like that. But if prices of a good are going up, that will and kind of generate the investment without it being explicit, and then yields will go up as well, all right? So most of them have price-sensitive yield functions. In the G models, you do have investment, so that if the rate of return to a specific commodity is going up for whatever reasons, you will see investment flow to that sector. Later I'll talk a little bit about endogenous technical change in the sense that, where it's driven by R&D and other factors, and very few of the models are actually doing that right now. So technology is by and large manna from heaven, unless there's price-induced changes, all right? But and this is one of the challenges I think we're facing. All right, challenges. Jerry, you led right to it. So the drivers, most of them are exogenous, so that's not really a challenge. What is a challenge, though, is technology. For most of us, it's exogenous, although sensitive to prices. We don't have R&D, and I think it was Ken that mentioned this. We don't know what the limits are, all right? Is it 12 tons, per hectare? Is it 16? We don't. And very few of our models are actually looking at the plausibility of those limits. Preferences is a real difficult issue for us to deal with. So, we normally calibrate our models to what we observe today, but we know preferences change over time. There's the dietary transition that still hasn't occurred in many parts of the world, and it's hard for us to implement those things kind of plausibly. I mean, we all have our different systems for doing it, and Hugo and I, amongst others, wrote a paper on that in the special issue. One thing we haven't really dealt with are policy reactions, all right? We just assume that policy is what it is, okay? You could think of the Russia export ban of several years ago. That's kind of a short-term policy reaction, but a long-term policy reaction might be India, which has to feed a growing population with very limited resources. Is India going to allow itself to be dependent on wheat imports, for 50% of its needs or not? The political economy would suggest no, it won't, because no country has ever done that in the past. So what are the implications for India if it decides that it wants to maintain food self-sufficiency for these key commodities? The other challenge for us in the dynamics is what new technologies are out there that are going to be available and at what cost. All right, we all have assumptions about we saw some numbers on bioenergy earlier. So that's again something that we're thinking a lot about. The other one, again, we mentioned. I think there's certainly going to be a lot of talk about the rest of the week is on volatility. Climate, so the way we introduce climate, mostly, for most of us, just exogenous change in yields coming from the upstream processes. Some of us have actually reaction curves in our model, but by and large it's exogenous. On adaptation, most of the models have some degree of adaptation, so there's going to be crop switching, input substitution, but very few of them go much beyond that in terms of actual investments in, for example, in irrigation or other adaptation mechanisms. Okay, almost none of them have process models, so we completely ignore kind of any intraseasonal effects that would be impacted by any kind of adaptation mechanism, such as changing dates of sowing and stuff like that. You've seen all this graph. So these are the linkages, the upstream, the climate signals, the signals on crop yields, and then the global economics. We produce the change in area, yield, consumption, trade. Some of us do nutrition as well, and there are other indicators. So we've already gone, I'm not going to, Christoph handled most of this, and we can talk more about how we can better coordinate there. On the downstream, all right, so we've already gone through most of these indicators. Let me just focus a little bit on the challenges, because these were challenges for us as well. So one is that none of our models really harmonize on kind of a spatial aggregation. So you have like impact and some of the other models are at the country level, but many of the G models are at the regional level. So Sherman might say something smart about Senegal. We might say something smart about sub-Saharan Africa as a whole continent or subcontinent, or some of us may actually say something about Western Africa, but very few of us are actually dealing with Senegal specifically. It's certainly not in the GE world. And the same goes for sectors. So trying to produce a set of harmonized results just in terms of dimensionality is difficult for us. We can do it at the world level because these are global models, but once you start going below the world level, it becomes more difficult. And we've already had some discussion over the last few weeks on how to deal with some of these issues. Definitions is a problem. So we were immediately confronted is, what is a world price? All right? So for some of us, for some of the models, it's clear what a world price is. For the GE models, it's not clear. It could be the average export price, for example, from all the countries, but we decided that was not a very representative world price. So we ended up using the output price, the average output price around the world as our world price, as a better indicator of the world price. Some of the other challenges that many of the models use indices instead of quantities, all right? So in my model, I don't actually have hectares. I'll have base year hectares in some units that grows over time. So I can tell you that land use will increase by 20% over 40 years, but my model doesn't immediately translate that into the number of hectares. So we had difficulties just kind of comparing numbers because of this indices versus quantities effect. And then finally, the downscaling is kind of similar to the harmonization. So, how do we downscale results from a model that has West Africa or Sub-Saharan Africa? How do we downscale that to Senegal, all right, or the other countries that create the component? So I'm done.